Today we're going to talk about functions. Remember, we've talked about relations, which were a set of ordered pairs. So now we have a special thing. Every member of the domain is paired with exactly one member of the range. Then it is going to become a function. So some relations are functions, some aren't. So every member of the domain, remember, which is the x-coordinates, is paired with exactly one member of the range. In other words, the domain can't repeat. So would this be an example of a function? A set containing the ordered pairs 1, 2, 2, negative 4, negative 3, 5. Yes, it would be, because 1 is only paired with one thing, 2 is, and negative 3 is. What about if we add this ordered pair 2, negative 3? Well, we see that the 2 is paired with negative 4, but here it's also paired with negative 3, so it would not be a function in that case. When you have a graph, you can use what's called the vertical line test. Remember, vertical line means a line up and down like this, straight up and down. If it drags across and doesn't touch one point, more than one point on the graph, it is not a function. If it touches more than one point, it's not a function. And then any equation, if it's a linear equation like what we've been talking about, will be a function unless it's of the form x equal a number. Because remember, when we've graphed x equals a number, what kind of line does that give us? That gives us a vertical line, so it would not be a function. So let's see if we can apply some of these and answer yes or no to these questions. And a lot of your homework today is yes or no. So is it a function? So looking here, how many of you think this is a function? Well, negative 4 is paired with one thing, negative 1 is, and 3 is. So yes, this is a function because everything in the domain is paired with exactly one thing in the range. Is this a function? Number 2, I guess I don't have my number here. Well, looking down here, what's paired? Well, we see 2 is paired with 5, but 2 is also paired with 4, so that would make this no, not a function. Now up here, notice the second term, the y-coordinate, or range, can repeat, but it's the first coordinate that cannot be paired with anything else. Well, is this a linear equation would be our question for ourselves. Yes, it is, so it would be a yes. This is a linear equation, but it's the one type that we said. Remember, if I were graphing this, I'd go over to the right 9, and it would be a line like that. So it is a no. So those are things you need to remember. Now we're going to use that vertical line test. I did just give us a blank slide here to put some graphs in. So if we're looking at this graph, so there's our graph, and we're given this thing here. Is it a function? Well, again, if you would take like your hand or a pencil and go across here vertically, it would only touch one point, so this would be a yes. It does get close down here, but this does keep going out just a teeny bit every time. So that would be a yes. What if I give you this? Here's your graph, and I give you this. Is this a function? Well, no, because when a line comes across, it touches 2 points, right here, and several other places, so that would be a no. What if we look at this on our graph? Well, we know the open circle means that point is not included, so in that case, this would be a yes. If I color that in that case, then it would be a no. So you have to watch out for that and look carefully. So if anything has 2 points that when you take your hand across your finger, pencil, or whatever you're using. So that's, is it a function? Now we're going to talk about how sometimes they write functions, and that's called function notation. And they use this, f of x is how you read that. So it does not mean multiply like we've learned before. So when you see the f, and it doesn't always have to be f, there can be other letters. A lot of times G and H are the letters they use. So it does not mean multiply. So if I were just reading this, I would read this, f of x equal 3x minus 8. So over here on this side, it does mean 3 times x. But over here, it's just called function notation. So you can evaluate a function. Here's my function, f of x equal 2x plus 5. I want to know what f of negative 2 is. So I'm putting the negative 2 in there for x, so I put it over here on this side for x. And then it's just a math problem. So this side, on the left side, will not change. I just do the math. This is negative 4. Negative 4 plus 5 would be 1. So f of negative 2 is equal to 1. Using this same function, I want to find f of 4. So f of 4 is going to be equal to 2 times 4 plus 5. And again, a lot of times I just put the equal. That means this left side carries down. 2 times 4 is 8. 8 plus 5 is 13. So f of 4 equal 13. Here's a different function. This one is called g of z. And it's equal to z squared plus 3z minus 4. So if we want to find g of negative 4, everywhere there's a z, we're going to replace it with a negative 4. So it becomes negative 4 squared plus 3 times negative 4 minus 4. So you're just going to do the math. Negative 4 squared would be positive 16. 3 times negative 4 would be minus 12 minus 4. 16 minus 12 would be 4. 4 minus 4 would be 0. And that's what we would get for this one.